So to start our discussion on the specific probability distributions, we're going to go ahead and start with the uniform distribution. Now, um, the big thing that I really want you to get from the different types of distributions is, first of all, you're not going to look at the probability of just one value. When you're looking at distributions like this, you're going to be looking at the probability of an occurrence between a certain range. And so to begin that discussion, let's start with the discussion of a uniform distribution. Because when you're finding that probability, what you are doing is you're actually taking the area under the curve. And with the uniform distribution, the shape of that distribution gives you a rectangle, which makes it very easy to do that calculation. And so the mean and the median with the uniform distribution are going to be equal. And all you really need to know is that maximum and minimum value designated by A and B so that you can calculate the mean, the standard deviation, and any probability that you might want to find. And so here we have our different formulas. So the mean of your uniform distribution is your bottom number plus your top number divided by 2. The P of X, the probability distribution, is going to be 1 over B minus A. And then your standard deviation is going to be the square root of b minus a squared divided by 12. So let's look at an example with this. We have a university bus providing regular stops every 30 minutes, and we can look at the probability of how long an individual is going to wait, given that we know that the bus leaves every 30 minutes. Okay, and so here our minimum wait time is 0 minutes and our maximum wait time is 30. So that means that the height of my graph is going to be 1 over b minus a. So 1 over 30 minus 0 to get me a value of 0.0333. And the length of my wait time is going to be 30 minus 0 to get a range of 30. So if we wanted to look at the entire area underneath that graph or that distribution, we get 30 times 1 over 30 to get a value of 1. And remember, when you have a probability of 1, that means that's going to include all the possible outcomes that you can have for that distribution. And so the mean for this example distribution is going to be 15 with a standard deviation of 8.66. Remember, the standard deviation is going to have the same units as whatever measure you're looking at here. So in this case, it will be minutes. And this measures that variation in the student wait times. So if we wanted to find the probability of various wait times, we can still use that formula where P of X is 1 over B minus A, and then multiply it by how wide of an area we have. Okay, so here the question wants to know, what's the probability that we're going to wait between 25 and 30 minutes? So our height is still 1 over 30, and now we're looking at a width of 5. So that means that it has a probability of 0.1667 of waiting for 5 minutes while waiting for the bus. Now we want to know the probability that a student will wait between 10 and 20 minutes. So now what we're looking at is this particular area highlighted in the middle of the graph. So 5 minutes below the mean and 5 minutes above the mean. So remember, we're still trying to find the area of that section under the curve. So the width of this is now going to be 10, but the height is still 1 out of 30. So 1 out of 30 times 10 gives me a 1/3 chance that the student wait time is going to be within that portion.